complex numbers, example 18. We're getting on to some quite lengthy examples here. This one's asking us to solve a cubic equation. So it's written it in terms of z. That tends to represent the fact that some of the solutions are going to be complex, otherwise I tend to write it in terms of x. And it's telling us that it has an integer root. By that it means one real root, and we know that all cubics have to have one real root and one, possibly one conjugate pair as well. So pause the video, use your knowledge of the factor theorem, and see if you can work out, by sort of trial and error, what the real root is that they're referring to. So obviously you're looking for a value that when you substitute it in gives you an answer of 0. So pause the video and have a go. So I hope you actually did pause the video and have a go and you're not just cheating. But I found that z equals 3 was the root, and if we just check it, 27 minus 9 minus 12 minus 6, and that does give you an answer of 0. So z equals 3, that is the root. What we need to know is the factor that goes with it. So you should be aware from C2 that the corresponding factor is z minus 3. So that's always true. Whatever the root is, in this case it's 3, you do z minus that thing in the bracket. So that's true whether it's real or complex. So next step, we need to work out what the quadratic is that goes with this linear factor. So again, pause the video, and what I want you to do is algebraic division. I want you to divide this cubic, z cubed minus z squared minus 4z minus 6 by the linear. If you do that by inspection, that's fine, as long as you can work it out and it's clear. Whichever method you do is fine. So have a quick go at that. And when I did the division, I got on the top line here z squared plus 2z plus 2, and obviously at the bottom, underneath all my working out, I got a remainder of 0. You should get a remainder of 0 because it was a factor, so you shouldn't have anything left over. So if you haven't managed to get 0 at the bottom and this at the top, have a quick check. So we know that our cubic can be written as z minus 3 and z squared plus 2z plus 2. Obviously from this one, the root is z equals 3. From this one, we're tempted to factorise, but I'm looking at it and I don't think it does. So we're going to have to do a quick quadratic formula. So again, you might want to pause the video and have a go yourself first. When I did it, minus b plus or minus square root of b squared minus 4ac all over 2a. And simplifying that, under the square root we have minus 4, and so that would be minus 2, plus or minus 2i over 2, and simplifying it, that would leave us with minus 1 plus or minus I divided by 2. Oh, sorry, I've divided by 2. Minus 1 plus or minus I, that's the answer there. So we've divided through by